Dependency injection is a technique to achieve inversion of control, also known as IOC, between classes and their dependencies. Azure Functions supports dependency injection patterns. This means you can segregate responsibilities into different classes and inject them into your main function class. Dependency injection allows us to write loosely coupled, well-maintained, testable, and reusable code. In this video, we will learn how to set up dependency injection in an Azure function, how the different lifetime scopes work in Azure Functions, and also some common use cases like application configurations, options pattern, etc. Hello everyone, my name is Rahul and welcome back to this YouTube channel. In case you are new here, I make videos around .NET, Azure, DevOps, and also AWS. So feel free to check the rest of the channel and also the linked videos if you want to learn more. Without much delay, let's head off straight into dependency injection in Azure Functions. In a previous video, I had talked about Azure Functions and how to get started. So if you are completely new to Azure Functions, I would highly recommend checking that out first. It will be linked here or in the descriptions below. Now, I will be using the exact same source code that I used in that video. The source code is also available in the repository. The links will be in the description again. So let's open up that in Visual Studio and get started with dependency injecting some services. I have the solution opened in Visual Studio. So here we have two projects. One is the queue storage and the other one is the weather data ingester. This is the Azure function, as you can tell by the icon in this project. Now, the queue storage is simply an ASP.NET Web API application that I had set up when I introduced Azure Queue Storage. I'll also link that in the descriptions below. Now here, there is a simple web API that drops a message from the weather forecast controller using the post method to an Azure storage queue. This uses managed identities to establish the connection. I walked through that in the video before. Now, the Azure function listens to messages inside this queue and gets triggered based on that. Now, this is using a queue trigger, as you can see in the function code, which is exactly on the same queue where we dropped the message in the previous web API. So anytime a message is dropped, it simply reads that and logs it onto the console. In case it contains the exception message, it throws an exception. This is purely for demonstration purposes. Now in your real life, these functions might be doing much more meaningful and business valuable functions. Let's run this to make sure everything is working as expected before we get refactoring some of this code to use dependency injection. Pressing F5, I have set up both the projects as startup, so it's going to run both these projects. Now, while that's happening, let's take a quick look at our Azure subscription, where I have a delete resource group, which I'll be deleting, of course, after this video, where I have the storage account that's getting used by these applications. Now, in this storage account, if I navigate to the queues section, you can see there is a add weather data queue. I have also set up connections for the Azure Functions and the Web API using managed identity. Now, if you're new to that, I highly recommend checking out those previous videos. This is done using the access control IAM section in this particular UI, and you can give relevant accesses here. If I navigate to role assignments, you can see the three contributors that I have added to the storage queue as a data contributor role. There is the function and also my local user so that it works in Visual Studio. Both the Azure function and the web API are running. The Azure function is running using the local function core tools that I had already installed. Now if you switch back to the API, you can see the get and the post call. Now this post call is going to drop a message into the Azure storage queue, which is going to be picked up by this function that is running here. I had a few messages already in the queue which got picked up here by default. Let's go and drop a fresh message using the web API post method. So let's go here and say try it out and give in a test string here. So let's say new test so that we can see this inside this console here. Let's click execute, which is going to drop the message into the Azure storage queue. Once that's successfully dropped, we should be seeing a log message in here, which is going to pick up this message and write it into the log statement. The message is successfully sent and it's also getting processed in here. So you can see a new message which says new test and it says it's executed. Now that we have confirmed this application is working, let's see how we can introduce dependency injection when writing Azure functions. So let's navigate back to Visual Studio and stop this and go into our functions1.cs class. Now this is where we have defined the function. Now let's refactor this so that we can introduce some dependencies. Now this particular condition, which checks on the myQ item, could be a big business decision for you in your application. So let's refactor this into a different class so that it can be checked and contained inside there. So I'll create a new class and call this message processor, which will process the message. So let's create a new class inside the Azure Functions and call this as message processor. So let's add a new class. Let's make this as public and create a new method inside this to process a message. So let's simply write public, which returns nothing, and say process. This also takes in a string message, which will be the message from the queue item. Now we can easily move the code from our functions1.cs into this particular class. So let's remove this from here and move this into the message processor class. So all this is doing is check if the message, let's replace this as message. If it contains an exception inside that, it will throw an exception. Let's extract this class into an interface so that we can inject it inside the functions class. So let's go on to the message processor class and press Alt Enter in Visual Studio and say extract interface. Now this is going to create an interface with this process method. I'll for now keep it in the current file. So let's say OK. Now that's going to add a new interface iMessage processor with the process method. Now I can start injecting the iMessage processor into the functions class for this particular check. So let's go into the functions1.cs and start adding this in. Now to dependency inject, we know that it has to be a class that can be instantiated. So first, we'll have to remove the static from this class declaration. So let's remove the static from the function class and also from the function method. Let's remove both these so that these are instance level methods and classes. Now to inject in the iMessage processor, let's use a new constructor. So typing in CTOR and pressing tab is going to create a new constructor inside this class. Now I have the functions1 constructor where I can inject in the iMessage processor. Let's call this message processor and use Alt Enter again to create and assign a property. So let's create and assign a field which is message processor. Now that's going to be a read-only field and it's automatically assigned that to the message processor. So let's start using this from the function again. So let's call message processor dot process and pass in the myQ item. Now this line is going to do the exact same check but using the message processor, which is now dependency injected inside this class. Now while we are here, we can also replace the function1 to match the name of the function. So let's copy this process weather data and rename this as process weather data function, which means I'll also have to update the constructor name. Now since both of these are updated, let's also fix the file name. Again using Alt Enter, I can say rename file to process weather data function. Now in the Solution Explorer, we have the files renamed as expected. With that all set up, let's wire up the dependency injections inside this Azure function. To do that, we need a new class which is the startup.cs. Now you can rename this as any file, but generally startup.cs is where we use dependency injection in ASP.NET Core. I have a completely different video on walking you through dependency injection in .NET. I highly recommend checking that out if you are new to dependency injection in general. So let's come here to the function and create a new class and call this as startup.cs. Let's make this public. For being able to use this startup class as a startup for the functions, we have to inherit from the functions startup class. So let's use functions startup and make sure to include the missing using statements. Now again, pressing Alt Enter, it shows the available actions. So we can install the Microsoft.Azure.Functions.Extensions NuGet package. So pressing Enter is going to find and install the latest version of that NuGet package into our solution, which makes this particular class available for us. The NuGet package is installed successfully, and you can see there is a new using statements up here. And also the functions startup class is resolved appropriately. Now let's make sure to implement this abstract class in our startup class. So let's use implement abstract class. This adds in a new method, which is an override of the configure method, which takes in the iFunctions host builder. Now this interface is injected into this class at runtime by Azure Functions. We will start configuring dependency injection using this builder. Now, to register this type for the function startup, we also need to add in an assembly directive. So let's say assembly colon and specify functions startup and specify the type of the class that's implementing in our particular assembly. So let's say type of and specify the startup class. So let's say weather data ingester dot startup. So now here we have registered this using the assembly directive that this is the startup class that we need to use for this Azure function. Now with that set up, we can start registering inside the builder the dependencies that's used for this particular Azure function. Removing this not implemented, let's say builder.services, and it starts giving us ways to inject into the service collection, very similar to ASP.NET applications. So let's first register the IE message processor as a transient dependency. We will come into scopes a while later in this video. So let's add transient. And if we resolve the missing interfaces, which again needs some usings, so if we include the using Microsoft extensions.dependency injection, we will get this method transient, which is going to take in the interface and the type that is implementing this interface. So let's say IE message processor and specify message processor as the implementation of that. Now this is going to inject this into the service collection as a transient dependency with this implementation. Now that we have all of this working, let's make sure to put a breakpoint inside the configure method and run this application again. Now we can also put a breakpoint inside the function class where we use this. So let's make sure to put a breakpoint on line 20 as well. And let's press start. Both the Azure function and the web API is running successfully. Now with the Azure functions, it has hit our breakpoint inside the startup class. So now this is going to set up the transient dependencies for this particular Azure function. Now, once this is run, it's going to set up these dependencies as expected. So let's continue the execution, which will continue the Azure function as well. Now let's go back to our web API and drop a message inside the queue. So let's use the post method and click try it out and say execute. This is going to drop a message with the summary string to the message queue. The message is successfully dropped and the Azure function has picked it up, which is why this particular debug point has been hit. Now this injects in the message processor inside this class, and we have this set up inside our class as a read-only variable, which is getting used inside here. So if we step in, we can see this calls in to the process message. Since this doesn't contain an exception, this continues execution as expected, and it logs the message inside this console. Now if we drop any number of messages, that's going to get picked up again by this function. Let's change the summary to be new message and click execute again. Now this is going to run the Azure function again, and it is going to log this message inside the console. Note that the startup.cs class ran only once at the startup of this function. Now this is very similar if you're running an ASP.NET application as well. Now whenever the host is getting instantiated, which is this CLI in this case, then the startup.cs is invoked once. For each message that's coming into the Azure functions, only the Azure function is getting invoked. We will see more about this when we learn about lifetimes a while later in this video. So let's stop execution. We have successfully set up dependency injection in Azure functions by injecting the IE message processor. Now if you look at this Azure functions, we can see that there is a log being used here. This is getting injected by the Azure functions runtime as the IE logger. We can also inject this using dependency injection. So let's see how that would work. Let's remove the IE logger from the function definition and use it from the constructor injection. So let's use IE logger. Now, if you are familiar with logging in .NET Core, we use the one with the generic type that also takes in the category name. Now, this is what is by default injected by the dependency injection in .NET Core. If you're new to logging, I highly recommend checking out my video on that, where I detailedly show different configurations and options that you can set on logging. For now, let's use iLogger, specify the class name, in this case that is the process weather data function, and use the name as log. Let's make sure to add a read-only property. So again, using Alt-Enter, I can use create and assign a field log. Now this again creates a read-only property, and this uses it inside this function. Since we are injecting the iLogger, we need to go into the startup.cs and configure logger for the services collection. So inside here, let's say builder.services and call the method add logging. This is going to configure the default log providers into this application. So let's run this to see if this is working as expected. Let's remove these breakpoints so that it continues execution without stopping here, and go back to our web API and drop a new message. So let's click try it out, change this message to be log, and click execute. The message is successfully picked up by the Azure function, and we have the log injected in here. So if you look at the logger, we can see there is a logger instance coming in here. You can also see the different loggers that's configured inside this particular log instance. Now these are the different configuration sources like the file logger, the null logger, the Azure monitor diagnostic logger, etc. Now there is a default set of loggers that's getting injected by the add logging method. Let's continue the execution and see if this is getting logged. But if you see here inside the console, we cannot see the message C# QTrigger function processed, which was using the log that was injected in. Now this is because of an existing issue, because of which it is filtering out all the external categories that we are logging. To fix this, we can stop this application, go to the host.json file and update it for the logging configuration. Now inside the logging, we can specify a log level and specifically call out the log level for our custom namespace. So if we go to our startup.cs class, we can see our namespace is weather data ingester. So let's copy that, come back to the host.json and set that as the log level information. Now if you're logging this to a file, we can also specify file logging mode as always. Now with the log level specified in the host.json, let's save this and run the application again and make sure it's working as expected. Now both the apps are running, so let's go to post, try it out and send a message again. So let's specify new log as the message and click execute. The message is successfully picked up by the Azure function, and let's continue execution, which should be logging this inside again. Now with the log level configurations, we can see that the message C# QTrigger also appears inside this console. Now if you deploy this into Azure Functions, you should be even seeing this inside the diagnostic console or the log stream of the Azure Functions. The startup class that we have used is meant only for setup and registration. We shouldn't try and use the services that's registered within the startup class, like the logger for example. Also, the dependency injection container only has the explicitly registered types. So if you're trying to resolve things like the binding context, execution context, etc., those aren't available as part of the dependency injection. Now that we have successfully injected in a transient dependency, let's understand a bit more about the different service lifetimes. Now, as with the ASP.NET Core dependency injection, this also supports the same three levels of lifetime scopes, which are transient, scoped, and singleton. With the transient, a new class is created whenever a class is requested for. With the scoped, it's only created once in the scope of that execution. In our case, it means a function getting run. And the singleton is just injected once, which is at the start of the host. Let's try and understand these service lifetimes a bit better with an example. So let's come back to our Azure Functions and create a new class in here. So let's create a new class and call this service lifetimes. Now inside this class, let's simulate a few of these transient, singleton, and scoped services. For that, let's make this first public, make this as an interface, and call this as an iTransient service. Let's add a method write, which takes in a message of type string. To implement this, let's create a class public class, call that as transient service, and implement the iTransient service. So let's make sure to implement this interface, and which has the write method again. Now to understand how this works, inside the constructor, let's also have a simple GUID property. So let's call this as random and specify GUID.newGUID and convert that as to string. So we can simply log this to understand how the scopes are working. Let's make sure to specify a read-only field for this particular property. So that's getting added inside this class as well. Now, if we want to log this message, we can also inject in a logger. So we can use a iLogger and specify transient service just like we did inside the previous example. So let's make sure to include the appropriate usings. So this is the Microsoft extensions.logging and specify this as a logger. Let's again add a read-only field and use this logger inside the write message. So I'm going to call logger.log information. Since this is the transient service, let's specify the message as transient. Let's also specify the message that's coming in. So let's use structured logging and also the random ID that we have generated. Now to set these, I have to set them as parameters. So let's make sure to pass in the message and the random in the correct order. Now all this is doing is simply it takes a message and it logs it as a transient and the message and with the GUID inside here. We will be using this to understand the lifetime scopes. Now we need similar interfaces for scoped and singleton. So let's simply copy and paste this. So let's name this as scoped and singleton services appropriately. So let's remove transient, specify this as scoped, and remove this and name this as singleton. Since we need different implementations, let's simply copy this class and paste this again 2 times and create the appropriate implementations. Now in this case, this is going to implement a singleton service. Instead of transient service, let's name this as singleton again. Let's make sure that the constructor is also fixed. And instead of this, let's name this as a scoped service. And use the interface iScoped service. So let's make sure the constructor is fixed again and give the appropriate names inside the log messages. So that's singleton and this is scoped. Now I have 3 classes which each of them represents a singleton, the transient and the scoped services. Now in your real application, these might be different implementations like a connection to an HTTP client or a database connection or some business function validations that you need to do, etc. Now depending on how you want, you will have to use different scopes and lifetimes for that, which you will understand how it works in a moment. Now with all of these defined, let's make sure to use them inside our message processor. So let's come back to our message processor and inject each of these inside the message processor. So let's again define a constructor for this and take in the iTransient service, which is going to be a transient service. Let's also add in the singleton service, call that as singleton service, add a field again. And similarly, let's also add in a iScope service, which is going to be named as scoped service. And make sure to again add a field for this. We will be using all of these from the process method. So let's make sure to align this appropriately and each of these parameters in new line. Now once we have successfully checked for the exception, we can simply use the transient service and call write and specify the type name in this case. So let's say we are calling this from the message processor. Similarly, we can do that for our scoped and the singleton service. Let's make this as scoped and let's make the last one as singleton. Now we have successfully created 3 different types of services, injected it into our message processor and logging out these messages from the processor. Now the last thing is to register these services inside the startup.cs class. So let's come back here and say builder.services and register each of these types. So the transient is going to be registered as a transient type. So let's specify add transient, specify the iTransient service, and also specify the transient service implementation. Now for the scoped, we'll be using the builder.services.add scoped method, which again has a similar interface, and specify the iScoped interface method in this particular case. Now we have the scoped service, so let's use that for the implementation. Now for the last one, it's going to be builder.services and going to be the add singleton method, which is again going to take a similar kind of interface structure. So let's say iSingleton and specify the singleton service as its implementation. Now, if you're not familiar with these extension methods, I highly recommend checking out my dependency injection video where I show different ways of registering these scoped lifetime methods and instances. Now, with all of these registered, we should be able to use this from our application. So let's run this and make sure it's working as expected. We have the web API and the function running. So let's click post, try it out, and specify lifetimes inside here because we're testing lifetimes, and click execute. The message is successfully picked up. So let's step into the message processor, and we can see the transient service, the scope service, and singleton service are all assigned a value. So let's continue the execution and see how the log looks like. Now we have three values getting logged here, which are the transient, scoped, singleton. It specifies these are from message processor and has three different GUIDs inside here. To understand how the lifetimes is working, let's send one more message. So let's name this as lifetimes new and click execute. This again gets picked up, so let's resume the execution. With the transient message, you can see the GUID is unique every time a new message is coming up. So if you see, this starts with 57 and the next one has a different ID which starts with C0. Now for the scoped, also this is same. It is different between different messages that's getting picked up. Now for the first message, it started with 299 and the second time it started with 265. With the singleton instance, we can see this starts with 5F6 and the next message also has the same instance, which means it is using the same singleton instance of that particular class in all the functions that is getting executed. So once the host starts up, it creates a single instance of that class and injects into the dependency injection. Any message that is getting processed by that particular host will get this same GUID. This is typically useful when you're using connections and objects like that in your real applications, where we want to reuse that connection and keep it open inside that particular function host. Now you will have to make sure that you are handling timeouts, etc., but this is generally what's preferable. To understand more about scoped, we will have to create one more dependency so that we can see what's the difference between scoped and transient. We know that both of them will be different for different message executions, but within the same message execution, there is a difference between transient and scoped. To understand that, let's come back to our application and create a new dependency very similar to the message processor. So let's open the Solution Explorer and create a new class. And for this, let's name this as another dependency, just to indicate this is some other dependency that you have in your application. Now I can similarly create a write method. So let's first make this as a public. Let's add in a method which is going to be very similar. So let's say public void process and call this as string. Now this is going to again process a similar message and write this into the console. Let's also specify a name, which is message. Now another dependency, let's go and create an interface. So let's say extract interface, add to the current file, which is going to add another dependency inside this file. Now I can inject this into the function as well. Now to use the same lifetimes, let's go back to the message processor and copy these message processor implementations. So let's copy all of that, come back and paste this inside our another dependency. Let's make sure to rename the constructor. In this case, this will be another dependency. Let's also add in the read-only properties that we need. So let's copy that again from the message processor and paste that inside our another dependency class. Now this is going to have the similar services injected in here. Now inside the process, let's simply call the write statements like we did inside here. So let's copy these three and paste this inside our process method, which is calling on to the transient, scoped, and singleton. Now since this is coming from another dependency, let's rename this as another dependency and make sure to apply this in each of these functions. So let's rename that, paste it, and also the last one. Since we've added a new dependency, let's make sure to use this from our functions. So let's go back to our process weather function. Instead of just injecting the my message processor, let's also inject in another dependency. Let's add a read-only field for this and start using this inside our run method. So let's call another dependency dot process and pass the myQueue item. Now, in your real application, this might be completely different and doing something else. I'm using this simply to demonstrate the lifetime scopes and how it works. Now, both of the my message processor and the another dependency takes in all the dependencies of those lifetime scopes. Before we run the application, let's go to startup.cs and register in the another dependency as well. So let's specify builder.services and specify add transient and specify another dependency. Now this is going to have the implementation as another dependency. Let's run this and see this in action. So for every message execution, we expect two sets of log messages for the transient, scoped, and service lifetimes, one from the message processor and the other one from the another dependency class that we just added. Both the apps are running, so let's go to the post, click try it out, and say lifetimes again, and click execute. The message is successfully processed. Let's look at the GUIDs again. So this time we have two sets of logs. So we have the transient, scoped, and singleton coming from the message processor, and also the transient, scoped, and singleton coming from the another dependency. Now if you look at the transient GUID, this starts with B451, which is different from the transient GUID from the another dependency. This is as expected, because with transient registrations, anytime you request for a class, in this case the transient service, it creates a new instance of that, because of which it creates a new GUID, and that is what is getting logged. Now with the scope service, if you look at the GUID, this time it starts with 091, and also the one from another dependency starts with 091. Both of them are exactly the same instance. With scoped, within the execution scope of that particular function message, the same instance would be reused. So when the message processor asks for the transient service, it creates an instance and reuses that same instance when another dependency also asks for it, which is why the GUIDs are same in this case. This is same for singleton. With singleton, a single instance is created even if any number of messages are handled by the same host, which is this console application that you're seeing here. Now if I go and execute one more message, let's call this as lifetimes new and click execute, this is again going to be picked up. Here you can see these IDs are slightly different again. The transient, which is B41, is different in each of these cases. So let's see for FC. In the transient here, it starts with CE and this one is DA. So every time a new instance is created. With the scoped, it's same for the first message execution, but it's different from the next. But you can see it's the same for the next message in both the message processor and also the another dependency. Both of them starts with 508. But this is definitely a different instance than the one that was used to process the first message. Whereas with the singleton, you can see it remains the same for all the messages. So you can see this is 6CB and also the first one used 6CB in all the classes, that is message processor and another dependency. I hope this gives you a good understanding about service lifetimes and how you can choose what you want for different implementations of your business functionalities. When we develop Azure Functions, we also need to use configurations. Now these configurations could be connection strings, URLs to other websites or APIs, and also secret keys. Let's see how we can use this inside the appsettings.json file that we are normally used to when building ASP.NET Core applications. So to do that, let's go into our Azure function and add a new appsettings.json file. So let's select add and search for the JSON file template. And let's call this as appsettings.json. So appsettings.json file. Now this is going to create a JSON file inside our Azure function. So let's say I have a config like this, which is my config, which has a URL and a secret key. Now, one thing to make sure is that by default, these appsettings.json file is not copied over into your bin folder, so it doesn't get packaged. So you'll have to right click and say properties and mark this to be copied always. So we can say copy to output directory and say copy always. This makes sure that this file gets copied into the bin directory and is available when we package and deploy as well. Now to start using appsettings.json file, we need to configure the configuration sources inside this Azure function. So let's see how we can do that. So going back to the startup.cs class, we need to override the configure app configuration method. So if we type in override, you will see a new method as well, which is the configure app configuration. Now using this, we can override the configuration sources that's used by this function. By default, it doesn't use the app settings, which is why we will be configuring this explicitly here. This injects in a iFunctions configuration builder, which is done by the Azure Functions runtime. Now, to configure the appsettings.json, I have some code already written, so let me copy and paste this here, and I'll walk you through it. Now, in this particular case, this is adding a JSON file, so let's make sure to include the appropriate usings, and it also used the path from the system.io. Let's make sure to include that as well. Now, all this is doing is from the builder, it's getting the context to determine the root path for these files, and it expects these files inside there. It uses the configuration builder, which is the same configuration builder that we use in ASP.NET Core, and specify the add JSON file. Now, if you're not sure about configuration and the sources, I highly recommend checking out my video on configuration in ASP.NET Core, where I walk you through all these different options. Now, all this is doing is adding a JSON file with the appsettings.json, specifying it as optional, and it says reload on change as false, which means if you change the file, it doesn't reload the Azure function. Now, similarly, if you have environment-specific configuration values like appsettings.development.json or prod.json or test.json, you can specify those files as well here. This also configures for the environment variables, if any, from the particular environment that this Azure function is running. Now with these specified, we can start using the appsettings.json file within our application. Now if you are familiar with the options pattern, which ties in with the configuration use cases, you can also use that with your Azure function. Now if you're not that familiar with the options pattern, I highly recommend checking out the video linked here or in the description below. The options pattern is just a way to start using the configurations from these files inside your application. Now in this particular case, since we have the myconfig, let's go and create an options class that is going to be myconfig options. You can name this anything you want, but for convention purposes, I'm going to name this as myconfig options. Let's make sure this is public, and we need two properties inside here to capture these values of URL and secret. So let's come here and create a string value. So let's type in prop and tab and say string and specify the property name, which has to exactly match with that in your configuration. Let's also add in for the secret. So let's specify string and a secret as the name. Now both of them has to have a public get and set so that this thing will work. Now again, check out that video if you want to learn more about options pattern in .NET Core. To start using this, I can go to one of our services, let's say inside our message processor, and use this from here. Now I can inject in an iOptions class and specify the myconfig options. So let's specify this as config options. Make sure to include the missing usings, which is the Microsoft.extensions.options in this case. Now you can add this as a backing property. So let's say assign a field and start using this from your applications. Since this is just for demo, I'll put a breakpoint to see how the value comes here. Now to register the options, let's go back to startup.cs and do that from our configure method. I have already written the registration code, so let's copy and paste that here, and I'll walk you through it. So this is calling the builder.services, the add options, specifying the options class, and specifying how to get this particular options class. So this is using the configure method, which takes in a iConfiguration, which is the settings and the configuration. Now using the configuration object, this settings class is nothing but the myconfig options instance, which is getting bound from the configuration section. Now if you see in the appsettings.json file, we have the myconfig as the section here, which is exactly what is referred to inside this get section. Now with the configuration, we have different sources defined using the configure app configuration. This is going to use the JSON file and also the environment variable. So this method is going to look for all the configuration sources, get the section for myconfig, and bind it with this settings property, which is nothing but a default myconfig options class. So all these properties will get populated from appsettings.json in this particular case. Let's run this. I have a breakpoint inside the processor, so see how this works in this case. Both the apps are running, so let's go to post, try it out, and specify the summary as configuration and click execute. The message is successfully processed. Now you can see we have the config options automatically injected in here. So let's do a quick watch on this using Shift F9, which shows the values of that my config options. You can see that it has the secret as my secret key and the URL that's coming from appsettings.json file. Now this is automatically read from the configuration settings, bounded to a strong type, in our case the my config options, and we can use this from our application code. Now anywhere you want these config options, all you need to do is inject the I options and you will get these options values as well. Now in this particular case, if we go to the appsettings.json, we can see we have the secret value specified inside the appsettings.json. This is not recommended. Now in an earlier blog post and a video, I had shown you 5 different ways that you can handle application configuration and secrets when you're working with Azure. Now this has different examples by using the DevOps pipeline or using Key Vault and also using Azure App Configuration. I highly recommend checking this post and the associated videos if you want to learn more about managing sensitive information like secret keys, etc. But one of the options that I show you for local development is to use the Secrets Manager. Now Azure Functions also supports the Secrets Manager. Now if you're new to Secrets Manager, I highly recommend checking my video on that, but I'll show you quickly how to use it from an Azure function. So if we come back to our functions, go into our Solution Explorer and right-click on the Azure Functions project and specify Manage User Secrets. If you click that, it is going to automatically create a new file which is in a specific location in your local computer. Now click Yes to install the required packages for this. It also creates a secrets.json file which is in a specific location inside your computer. If you can see, this is under the app data, roaming, and a folder that's dynamically created, which I walk you through in my Secrets Manager video. Now one thing you need to note is using the Secret Manager is not a sensitive way to use it in your production environment. This is simply a way on your local computer to keep the secrets outside of your app settings file so that you don't have to check it into a source control. Now if we go back to our appsettings.json, let's copy all this and paste it inside our secrets.json file as well. Now since we are okay with the URL to be in the app settings, let's remove that and specify the secret as secret from secret store. We can also go to appsettings.json and remove this from here. I usually have this as empty so that anyone looking at the application.config can clearly know what all configurations is supported by this apps. Where this is set is up to me to decide finally. It could come from Key Vault, or it could come from Azure App Configuration, or when I'm using local development, it will come from the secrets.json. So let's make sure to save all these files and run this application again. So this time, when the application runs, it should pick the secret from the secrets.json, which is living in your computer. Now, if some other developer is pulling the same source code, they can set up the secrets in their local machine as well. This way, you don't have to share the secrets using your source control. Both the applications are running, so let's go into the post, try it out, and specify the message as secrets in this case, and click execute. The message is successfully picked up, so let's select the config options and do quick watch using Shift F9, and we can see the value as secret from store. Now in this case, only the secret is getting replaced from the store, and the URL is coming from appsettings.json itself. Now similarly, you can have appsettings.development.json, etc. overriding these values as well if you want different values in different environments. I highly recommend checking out that blog post where I walk you through 5 different ways where you can configure sensitive information and configuration in general for applications running on Azure infrastructure. I hope this helps you to understand more about dependency injection in Azure Functions and how to set it up from scratch. We saw the different lifetimes, Transient, Scoped, and Singleton, and how it differs with the running instances of Azure Functions. When these functions are hosted in the Azure Functions in the cloud, it behaves exactly the same, which is why I haven't demoed this in this particular video. But when I do a video on hosting and scaling, I will show some of this again. We also learned how to use application settings.json file and use the app configurations that we are used with when we are building ASP.NET Web API applications. We also saw how to use options pattern and to use the secrets manager. If you like this video, please make sure to hit the like button. And if you want to be notified in the future of similar such videos, make sure to hit that subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.